So hey guys. So I'm I'm Rafael from Giza. I'm developer lead and I'm building the what? I'm building the Orion library framework. You will understand more later. Um, and the idea, what we are doing at Giza, we are building protocols for a more transparent AI ecosystem. And the idea with Orion is to create a framework for verifiable machine learning. So first of all, why verifiable machine learning? I strongly believe that AI models are becoming more and more big in terms of computation. So we can't run it from our own device. So we have to delegate the computation to a supercomputer. But the problem with that is when you delegate something, for example, when you are using ChatGPT, you have no idea about what they are doing with your data. You have no idea if the result that they return was not biased, and you have no idea if they use the model that you ask. Maybe you ask for GPT-4 and they are using GPT-2 or GPT-3. So it's like a black box. We are all using API, but this is a real problem because we need to verify the validity of the inference. What is beautiful with Cairo is that it's programming language, provable programming language that doesn't return only the result, but that return a proof that you can verify. Okay, so what we are building with Orion, the idea is to make the inference of machine learning where we will be able to verify the result, okay, the validity of the result. What we do at Giza, as I said, it's like a trustless protocol for on top of Starknet, and we are building tools on top of Orion to build more to build this transparent AI ecosystem. Here, if you scan the QR code, you will have like a Notion page with all resources, if you want, with all resources, documentation, etc. So this is what is Giza. Now, what is Orion? Orion is an ecosystem for validity and ZKML. We have three main components. The Orion framework. The idea is to create a framework for validity ML compliant with ONNX. Orion Hub. It's a created list of models and spaces. The idea is to make a Hugging Face for verifiable machine learning. This is what we do with Orion Hub, and Orion Academy is all resources, tutorials, etc. that we are building with Giza and with Orion. We launched that 2 months and a half ago. So for the moment, there are only 2 tutorials, but in the future we will have much more resources. In the Orion framework, we have currently 3 main libraries. Numbers with a full implementation of signed integer, because for the moment Cairo doesn't support signed integers, but it will be in the future, so that this is temporary. Fixed points with the idea is to implement a fixed point. For the moment, we have 2 kind of implementation of fixed points, 16 by 16 and 8 by 23. But anyone can create their own implementation because it's just a trait. And in the future, we will add more implementation. Just before, I can show you in the documentation, the fixed point, the numbers, signed integers of fixed points is only a struct with the magnitude and the sign. And here you have all functions that can be applied to the fixed point. Okay. Then we have the operators library. where we have tensor and neural network traits. So in the tensor traits, it's a trait with all functions for a tensor, very close to an NumPy library. I can show you here. We have like ravel, unravel, reshape, transpose. So very similar to an NumPy. Again, we are compliant with ONNX for that. What is a tensor in Cairo? We implemented that as a struct with the shape, the data as a flat array, and extra parameters. What is extra parameter? It's all parameter that for a context. For the moment is the fixed point, because even if you have quantized tensors, we can have for some intermediary calculations like a softmax, we can use a fixed point. So it's a way to say to the tensor, it's a context that you give to the tensor when you say, okay, if we have intermediary calculation with fixed point, use that implementation, you see. So this is the tensor library, and then we have the neural network trait, where we have that will deal all functions on all functions on to create your neural network. Okay, so again, we launched only 2 months ago, so we have that functions implemented. In the future, we will have much more. In the Lambda ZK week, someone created the conv, so we will I'm gonna review the PR, and next week the conv will be of 2D, I think, will be implemented. And the idea is that anyone can implement their own operators, of course. So yeah, these NN trait, the idea is to build your neural networks, to give you all the functions to build your neural networks. And then we have the performance. In the performance is everything related to the performance of your model. So for the moment, we implement quantization in the performance. Currently we have static linear quantization, but in the future, and I think it will be next week or in the next week or in 2 weeks, the dynamic quantization also, and we have the dequantization already implemented. So this is about the OION framework. As I said, we are compliant with ONNX. So for people that doesn't know what is ONNX, it's a standard for interoperability in machine learning. It's a way to for example, you have a model that was built with a framework, PyTorch, TensorFlow, that you can easily convert it to another framework. We support currently 21% of operators from ONNX, but again, we have 2 months. So in the idea, our target is to have a full compatibility in November for DevConnect. And I will show you some tools that we are working on that could be that are nice, and that will be nice to hack for DevConnect. Tomorrow I'm gonna hack with some contributors on the INSUM to implement INSUM. When INSUM will be implemented, we will be able to abstract many operators, many linear function operators, thanks to Einstein summation. So this is for ONNX. Now at Giza, so OION is much more than Giza. Okay, the idea with OION is to create a library, a framework for verifiable machine learning. What we are creating at Giza is it's a product on top of OION to facilitate the process for developers and create that AI transparent ecosystem. Okay, so now at Giza we are building that CLI and transpiler. The idea is in the idea that you can train your model in the framework that you want. It can be PyTorch, TensorFlow, and then transpile it to Cairo code. Cairo Orion code with just one CLI. Okay, so it's already working. It's just that for the moment we only transpile weights, but in the future we will support also. It will also create the graph for you. So what it returns? It returns a Scarb project. Scarb is a package manager for Cairo, with all your layers, with all the weights in your layers, and then the graph, the graph of your model, where you will be able to run the inference. All our Cairo code, of course. Okay, just before to talk about that, our vision with Orion is to why I'm saying that it's a framework and not a library is because our vision is to support much more stacks than much more backends than Cairo. So the idea, Cairo is a way to have verifiable machine learning, but the vision at Giza is that if we want a transparent AI ecosystem, we need verifiable machine learning and privacy. So we will add in the future different backends like Noir for stacks and or plonks. And so the idea is to have different backend in the future. So we start with Cairo, but in the future with the same transpiler, with the same CLI, you will be able to take your model, transpile it to Cairo code if you want, or to Plonk or to Noir or other languages. I don't know if you have time, but I can show you with the MNIST example. So I can show you how to create a simple neural network with MNIST. So what I will take, so in this QR code, you have the repo, okay, if you want to check it. Yeah, sure. I can send all the links that I talked about. So here, let's start from the beginning. So here I just import everything, the requirement. I install Rust and Cairo in my notebook. Then what we will do here first is that we will train our model with TensorFlow. I'm not using ONNX here because it's really simple and the transpiler was not mature at that moment, but the process will be you train your model, you convert it to ONNX, you can quantize it because we are working only with quantized data for the moment, and then you can transpile it and then do the inference. So here we will train with TensorFlow. We will separate in training and test set. We will train it. We define the model. You see it's a very simple model, a dense layer with a value, loader dense layer with softmax. I just resized my images to 14 by 14 instead of 28 by 28, just for better performance. Here I train it. And then because I'm working with quantized data, I like to do quantized aware training. For people who are not familiar with it, it's a way to fine tune my model with more with quantized data set. So my model is aware about quantization. So it will improve the accuracy in some cases. So this is what we do here. We just retrain the model with QAT, quantized aware training. And thanks now that our model is aware with quantization, we are able to quantize it. We'll quantize it in integer 8. And then let's just test it to be sure that everything is working well. Again, it's TensorFlow. So this is what we do here with one example and with some example here. Okay, but now that we train my model in TensorFlow, what I want is to make the inference in Cairo. So what I do here, I will convert my model to Orion's Cairo code. Again, when we will do it with the transpiler very soon because it will be major. But because at that moment it was not major, and I think it's also a good way for you to see how it's working. It's a very simple script, okay, that they one of my inputs, it's the digit 7 in my data set, and then take all weights and biases from different layers, and from that values it will return Cairo files. Okay, so this is what we do here, and now when I run that script, it generates a new folder that is here, and as you can see, I have all this is the biases of the first layer, the weights of the first layer, the biases of second layer, the weights of the second layer. Okay, and one of the inputs that I asked. Okay. And now that we have generated that, what we need to do is to build our neural network. Again, with the transpiler, it will do it for you. Okay, so you don't have to do it manually, but I think it's a good way to see how it's working. Okay, so if you remember, we have a first dense layer with a ReLU and a second dense layer with a softmax. So this is exactly what we do here. We have these fully connected one where we import the linear layer from the neural network traits. We put all the inputs, weights, and biases, and we then call the ReLU from the result of the linear, and then we do the same for the fully connected with a softmax at that time. Now that we have that, we can test it and run the inference. So here what we do, we import all the inputs, not only one of the inputs, the biases, the weights, the biases of the second layer and the weights of the second layer. We start by doing the first layer, running the first layer, the second layer, and because this is a test, I want to assure that all indexes are the priority is 0, except for the index as 7, because my input I set it was the digit 7, and this is 1 in the representation of a fixed point 16, 16. So I want to ensure that the probability at that index is almost 1. So this is what we do here, and as you can see, if I test it, it worked. So this is for the test. For the inference, it's almost the same code than that. It's just that instead of having that in the test, you can just create a file inference.cairo that return the argmax, for example, in our case. It's just that why I did that in the test, because currently there is a bug in Scarb where I don't know why, but Scarb Cairo run doesn't work. So I reported the issue to the Scarb project. They are working on it. However, Cairo run is working. But the thing is that if you want to do it, so you can do it, but if you do it without Scarb, it means that there is no package manager. So you have to put all the code in the Orion repo because there is no dependencies. So that's why we do it with I did that with the test, but it will be fixed I think very soon. So voila, some changes that will be done during that week. You see here until few days to create arrays in Cairo. It was like you just have to initiate the array and then append. They released a new version a few days ago with the array macro. So now we can just, very similar to Rust. So now we have array, exclamation mark, and all our values. Okay, so that will improve a lot the performance. Also, we have this I32 implementation. But what we in the future and very soon, they are working on the sign integer in the core lib of Cairo, so it will also increase a lot the performance. Voila. Do you have any questions?
So right now, the generated files from bias file and weights, they are all from the train model in Python, right?
Yeah.
So is it possible to train the model inside Cairo?
No. No, for the moment we are really focused on the inference part, because I think it's good enough for the moment. Of course, it's not like ideal, and the training is another deal. Training in Cairo, it's another deal, because how do we manage the backpropagation? That's a good question. So for the moment, we are focused on the inference, and with that, and something that I didn't mention, but with that we can do both. We can do verifiable machine learning off chain, but also AI on chain, because it's Cairo. You can work on. You can deploy and encapsulate to a smart contract and design it as a smart contract and deploy it on chain. So we are focused for the moment on the inference more than the training.
So do you deploy on the Cairo?
On chain. So we are trying different approach for the moment. First of all, how do we? Until now, I was really focused on Orion and build first operators. We are trying different approach on how to deploy it, how to represent the smart contract for weights and biases. Where do we store the weights? Do we hard coding in the smart contract, or do we add that in the storage, or do we create another contract only for weights and biases? I'm working on a project with Dojo. Are you familiar with Dojo? It's a game engine for in Cairo. We are working on a POC called Drive AI, and the idea is to train a model to train a car to drive in a game, and export the weights and biases, or export the parameters and deploy it as a smart contract, so we can make the inference on chain. So I think I'm gonna have an answer about the performance part, etc., in the last few weeks. Because we will do it with Madara. My assumption and what we think at Giza is that if you want to have good models, use L3. L2, it will not be able, at least for the moment, to deploy it. And Madara is a very good way to create easily layer trees. If you want huge models, in some industries, you don't need, all models doesn't have to be on chain. Okay, I strongly believe that you can do a lot of things off chain, but verifiable, and you can verify it in local, because the verifier is very small, so you can do it with your own devices, or you can verify it on chain. Okay, so what is great with on chain AI is that it superpower your smart contract to be really smart, but with verifiable machine learning, I think it's on-chain AI is a part of verifiable machine learning. Like, verifiable machine learning is more than only on-chain AI.
I don't really know about Star. So if you deploy this Cairo thing, so does the actual model run on the chain?
So the inference ran on the chain. So that's what we are working on now. We are working on some approaches, and And so I think I'm gonna have an answer in the last 2 weeks. Like we are working on that now. We were not focused on the on-chain part until now because we were really focused on how to build first operators. The on-chain part is not a real problem for us because I think the main part is to make it verifiable, you see. So that's why we were less focused on chain, but Dojo wants to try it, so we are working on it. So.
Actually, I just want to know because Vitalik actually today at the conference I'm talking about the aggregation of smart, but it's not necessarily for smart, but it's like for in general stats, it's okay to do aggregation of these things. Therefore, you guys probably be like solutions as far as like you can aggregate a couple of the computation kind of thing altogether to reduce the gas fee and
that's interesting. Yeah, definitely. That's an interesting approach. And and L3 in general are great. So this is for on-chain AI. For off-chain, for the inference, we are thinking also on different approach for the inference in off-chain, because of course, if we are doing the inference only with Cairo, the performance will not be the same than a Python code. Okay. So one of the architecture that we think is that so Lambda class that created that worked on the last version of Cairo released Cairo, Sierra to MLIR. Which is a way. So Sierra is the intermediary representation before to be compiled to the Cairo VM. And the idea is to take the Sierra file and convert it to MLIR. And thanks to that, the performance will be much better. But the problem with that is that it's not provable. So what we think is that we can do it asynchronously. Like the same Sierra file can run with MLIR and be very, very fast with some parallelization, etc. And then asynchronously we can prove it. And I think in terms of user experience, it's okay. We don't need to have the verifiable part on time. It's okay if it's coming a few seconds or minutes after the inference. So this is what we think about, and with the provable part, we can use any prover that supports Cairo. So there is Sharp, but there is the Lambda class prover that is really interesting because we can use GPUs for that. We are working with Andrew Mills that created the mini Stark that is creating Sandstorm, which is a prover with only 64 bits. So it's very small prover. So and the idea is that anyone can use the prover that they want that supports Cairo, of course, to prove it. So there are different stacks that they can use. The idea is to be the most modular as possible. So it's working with the project that you want.
So I have a more general questions. Is that especially for use case? Because as you mentioned that, I think it's also like especially for the big model, it will be like workable, just like have a verifiable environment and you want data right here, and then you secure the data is like a correct one and you go online. So from you say, what do you think is like not have to, but it's like better to run the like model or doing actually like on-chain AI, or you have like you better to run this model online? Could you give me like a use case?
I think it's like a use case of what of the
better to run online, like the model online instead of just like probably very verifiable environment offline.
So you mean like use case to run on chain instead
It's
of
better, yeah, better than off chain.
no, it's so on chain. Like it's a way to avoid the away code problem, to have to be in a trustless environment completely, and to get the information from the smart contract directly. We are working with on different POC with some DeFi protocols where we can have ranking algorithm in smart contracts. So this is interesting. More for what is interesting with on-chain AI is that you can superpower your smart contract with ML models, because now the computation in smart contracts are very simple and they are close. They are they don't have that the same capabilities than Web2 computations. So so this is a good way to have to unlock the machine learning to some smart contract. It doesn't have to be deep learning. Okay, it could be some machine learning or statistical algorithm. With Orion, you can do many statistical algorithm. So that's what we want also to do. So it's a way to unlock that. It doesn't have to be a huge model. It doesn't have to be deep learning. But I strongly, I believe that if you want to do a ChatGPT, don't do it on chain. I don't see I don't have a, I don't see, it doesn't make sense to do it on chain, I think, but maybe someone has a good project to present. But so you can do it off chain, but you can do it verifiable, and that's I think the most important part. I think blockchain is just a way to be trustless, but everything doesn't have to be on chain. And what is matter is, okay, we are creating a trustless environment, and this is the most important part, I think.
But you think it's possible to force smart contract to actually running like AI like algorithm technically, because like right now it's like smart contracts so limited by the technical like issues that can slow
I think L3 is a very good opportunity for that, because you design the layer tree that you want, you know.
Okay.
And so I think the layer tree is it's an amazing opportunity for that.
That makes sense. Thank you.
And so what was it close right now to Wi-Fi in the first process?
Now with what we have now, if I want to verify that, first of all, I have to prove it, because Cairo doesn't generate the proof. With Cairo, you have a trace, but you can't generate the proof. So you have to use the prover that you want. You can use Sharp, which is the prover of Stacker. I think it's much more like an API, like you send it and it's a black box, but it's the prover of Stacker. You have Lambda class prover, which is open source. And I think that's it for the provers. There is this Sandstorm prover of Andrew Mills from Ministark, but it's not ready yet. So I think the Lambda class prover is a very good one. They support Cairo 1 and all built-ins, and also they support parallelization with GPUs. So that's great. That's great also for us. And to verify it depends on the prover that you use. But if you prove it with the Lambda class prover, you can verify it with the same prover, with the Lambda class verifier. So.
One question about.
And just sorry. And the verifier of Lambda class is not on a Solidity smart contract yet, but they will. I think in 2 weeks. So you will be able to verify it off chain or on chain, and that's good. Sorry.
So for very big models, I think this is going in future. But for very big models, like something like convolutional neural network, things like that. given that there are limits to what can be run in a parallel contract, and also when you're trying to prove, from my understanding, at least if you are proving something that's very huge, it contains a lot of lines, a lot of parameters. I assume that the constraint increase and proving it will become much harder. So for something with a lot of parameters like convolutional neural networks, what will be the solution, or like what will be the way of going, like implementing?
So first of all, something that is great with stack provers is that if it's increasing with a pseudo logarithmic curve, so it means that even if the model is big, it will be almost the same proof than with a small model. So that's great, because the MNIST model and a GPT model is almost the same to prove. So that's great. Then we have some questions about the compilation part. Like we are encountering some issues now on, okay, transpile it from Cairo to Sierra. When it's a huge model, sometimes there are some errors, and some actors in the Lambda ZK week, they encountered that error when they did that with the CNN. With some performance, with some optimization that we are doing, for example, as I show you with the new way to write arrays, and when we will remove signed integer, it will be much better, because there will have less, the file will be smaller. I tried that project is 108 KO. I tried with the new version of the array, it's 85 KO, so it's reducing, and it's without implementation of signed integer. When signed integer will be implemented in Crowley, it will reduce. Okay, so this is array. Another ways that we think about is to, instead of writing Cairo code and transpile it to and compile it to Sierra, writing Sierra directly. We can think about like templates, you see, and then what is changing, and we just write Sierra directly. This is another way. Another thing that we are thinking about, and that is interesting also for on-chain AI, is to split the model in different files, and for on-chain in different smart contracts. That's interesting. So we can do it by steps. So that was an approach that Giza, are you familiar with him? It's a magician in the Starknet ecosystem. He tried many things before, like 2 years ago, something like that, and he tried to make a neural network 2 years ago, and he did that by splitting the weights in different smart contracts. So that's also an approach that we are.
One more question. So Giza is trying to support Onyx. So considering Cairo right now, Cairo V and Cairo in general right now does not have I/O libraries, right? So how would the reading of the Onyx file, like loading of the Onyx file into Cairo work? Is it just something like Giza where it will automatically generate the Cairo contracts, or that would they be? Are you considering using something like Giza to pull in the weight, like what you're doing right now, or is something like an I/O library required, or these will be better in a sense because of?
So if I understood well the question, there is no I/O in Cairo. So what we do is that we take your model, we see the graph, and then we just map. We just take, okay, you have a video. Let's take the video in your in Orion, and we we generate the Cairo file, and then this is for the graph. And for weight and biases, we just take all values in your tensor, and we recreate the tensor in Cairo. So this is what we do. We transpile it because there is no I/O in Cairo, so it's a way to. So if you want to represent an object in Cairo, you have to convert it to Cairo file. Before to work at Giza and before to work on that, because I started to work on the before joining Giza in January, I started to think about, okay, how we can represent tensor in Cairo, how we can represent like the fundamentals of verifiable machine learning in Cairo. So I created a Cairo ML project. But before that, because I'm a musician also, I try to make on-chain, I try to make on-chain music just for fun, and how we can represent MIDI on-chain, etc. And so I did an experimental project where, because MIDI is very similar to a JSON, it can be represented as a JSON. I created an experimental project where we can just take any JSON and represent it as a Cairo smart contract. It was built in Cairo 0, so I have to change it now, but it's working well, and that's great because you can represent as a smart contract any JSON like object. So it can be MIDI, it can be 3D models, it can be many things, you see, and it can be positions of a dancer in a it can be great, it can be a lot of things, and artistic project I think it's great. But you see, there is no IO, so to do it I have to convert it to a representation, a Cairo representation of the object. So
I imagine that would become difficult for anything area, like even images you have to convert it or encode it into bytes, which you are sending in. That's I think, yeah.
Okay. Any other questions?
It is cool.
But we can just join everything. We can like make generation of MIDI.
I really like the music stuff, but I find it was like too complex. So if you want to have or do MIDI on the car, it's a big project.
Yeah.
Also like
That could be great.
Yeah.
I thought also about maybe for game, could be on-chain game could be great, and I think it's a great project for Orion. Music generation with a Markov chain, so we can use Markov chain to generate music on chain, and that could be great. And you see that's okay. It's a fun use case, it's not a business use case, but it's a use case where okay, you can make and you can have a hidden Markov, so you can have ML models that are not deep learning but are working on a chain, and that could be great, And for on-chain games, it could be great, like the music evolves based on the action that you are doing in the game, based on the skins that you own in the game, so the NFTs that you own, etc. That would be awesome.
I think it's like if you can use enough data or random libraries on chain to kind of generate the game or generate characters, it will be super cool, and it will be really hard to do off chain because you don't want to go off chain, go back off chain. So I think it's the only thing that it's a limitation of the infra level, especially it's right now. So it's like we have nature to have a better efficiency kind of stuff. It will be lots of things come up.
Yeah, definitely.
Alright, guys, if you don't have any questions, I think we should kind of call it a night. It's before starting.
No problem. Of course.
I'm just looking at
No, but I think this has been super important for us.
It was great. I liked
I was
it.
expecting Giza, but then the art part is much.
Yeah, that's
that's Amit online. That's our hacker. He's also
Oh,
your
awesome.
government.
Hey.
Damn it.
Yeah, so Giza and Orion is related, you know. We
I
are
actually didn't know
building.
before this, but I know both of the projects. So
Okay, you
this
thought that
is
it was
very
two different
cool.
projects. No, but that's great because again, we want that even if we initialize that Orion framework and ecosystem, we want that it's an ecosystem and not a company. Giza is the company, and we are building third-party tools for Orion and to facilitate the ecosystem. But the idea, we are thinking with a dojo to add Orion in the dojo stack also. So the idea that many projects or companies can create their tools for their own use cases on top of Orion, and that's also why we want to support different backends, because I'm not Cairo maximized, you know. Cairo is beautiful. I just.
You are.
Yeah.
If you're not, who is the Cairo?
I'm more a trustless maxi than.
We are all in that sense.
Exactly. So yeah, I think there are many projects that are great with different backends, and that's why we want to support that backend. And ZKL, it's amazing what they are doing. Circumlib also, CircumlibML, etc. And what we love with NNX, and I think that's why also we are compliant with that. It's because it's a way to because we are both in with NNX, we can take a model that was in ZKL and convert it easily to Cairo code with Orion and vice versa. You know? So that's great because we can just rely on backends and have an interoperability between everything. And I think the most important thing, and it's in the philosophy, the paradigm of Web3 is to have interoperability. You know, it's so. Voila.